chat box up in Zoom. So can you see if we can
Yes, I'll be using that one here. Just get rid of that. Hi, good evening. I do apologize, as I've done to everybody here who has joined us face to face, and I hope everybody at home who are joining us on Zoom can hear me. This is something new that we have been trying for the first time, and I hope we're successful with it. But my name is Anuj Thir. I'm the Sustainability Engagement Officer at Ku-ring-gai, and I'm filling in for James Chan, who actually runs the Climate-Wise Community Program and the Water Smart Program, part of which this presentation is of. Our presenter for tonight is David Knights. David Knights is a very experienced environmental engineer. He has over 20 years of experience in green infrastructure and sustainable water management. He's in fact been holding or carrying out a lot of presentations and workshops for various councils with regards to the subject. So if you could give me 5 minutes, or not 5 minutes, 5 seconds for me to go back onto my seat, but I think you should be all right with this. Yeah. Thanks. Forget to just mention, put the questions in the Q&A and we will get to it.
Yep, great. So online, for those online, let me know if you can't hear me. I've just plugged this mic in. Let me know if the sound works. And yeah, type your questions into the chat box, and hopefully I'll remember everyone is online as well, and I don't just forget you. So welcome everyone. Thanks for turning up on a Thursday evening. As I was jokingly saying, we don't actually know how long we're going for tonight. I suggested 6 hours, so make yourself comfortable. I like to start just by going around, and for those of you online, just fire away into the chat box why you have turned up tonight and what you're interested in finding out about, any particular issues or any particular things that you're interested in. And I'll try and cover those off as best as I can during the session. So I might start in the room. You go up the back, and I'm just going to translate what you say back onto the onto the Zoom, because I won't be able to hear you. So yeah. Yep. 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 So we have a wild garden in Wahroonga, and we're looking at doing up the landscaping in the wild garden. So here for ideas. Yep. 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 Yep, great. So we've got a steep block in St Ives. Looking at drainage, has been very wet after this lovely dry weather we've all had. Yep. 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 We've got another steep block. Yep. Yep.
So I'm here for water sensitivity in both terms. So we went through that massive drought.
Yep.
Where the garden's sort of struggling because of no water.
Yep.
Now we've got the complete opposite, where there's just too much water. Yep. And everything's growing, so no matter what, it's just growing. So what I'm specifically looking for is the property we bought was the typical, I guess, people bringing in plants that are not native and wanting to change some, especially just the lawn, changing it to a native lawn rather than having to mow it.
Yep.
That kind of
yeah. So we've got another steep block in Kalara, interested in both how to manage droughts, which we've all forgotten about, and how to manage the wet periods as well, when there's lots of water around. Yep.
Also a steep block.
Yep, another steep block in St Ives. Yeah. I've got all 4 steep blocks so far. We should have a poll here, quick straw poll. Yeah. Yep. Yep. Similar. Okay, great. Yeah, we're just going around and just, yeah, what motivated you guys to turn up tonight? You can speak together or speak individually. Yeah.
We're on a really steep road,
Right.
on a terrace.
Yep. It's a competition. We've got the steepest block so far.
We're
Yep.
on the sandstone.
Yep,
We've got
sandstone.
Sandstone cliffs behind us. We've
Yep.
got a sandstone cliff in our front yard that turns into a waterfall.
Yep.
And we've actually had we've had massive flooding during this wet
Yep.
period. And we've actually had so much water that things aren't growing anymore.
Yep. So
some things are, but a lot of stuff's drowned. So
yeah,
we're obviously keen to find out what we can do with plants to sort our drainage.
yeah, sure. So yeah, flooding and drainage issues, waterfalls, and so much water that the plants aren't surviving. For those of you who've just come in, I'm repeating everything, not because I like to do that, but because we're also online with Zoom. And so I'm just translating what you're saying back to everyone online. Yep, at the back. Yeah, we're just asking what motivated you to turn up tonight, or what you'd like to find out about.
Well, we just want to find out, similar to this lady.
Yep.
With massive water, all seepage through the ground.
Yep.
We've got a channel, and they've got some irrigation piping in the trench, but the water is still seeping.
Yep.
They're halfway down the slope.
Yep, great. So we've got another drainage issue, lots of water coming off sandstone. And yeah, you can. Yeah. Yeah, do you want to come sit at the front? Yeah. And then Anuj from the chat box.
Lucy has mentioned steep blocks seems to be the theme. We have steep blocks and want to build a reed bed to improve drainage while retaining some water for a wishful dry period. So looking for ideas about reed.
Okay, great. Okay, so that's great. So what I'm going to do is, as we talk through it, I'm going to, as we go through various things, like I've got slides prepared, but I'll tweak them and modify them and just talk to the issues that you've got. And at those points, when you've got particular things, just prompt questions. I like lots of questions and digressions. It's a way for you guys to make it more specific to what you want. So if something comes up and you go, oh, how do I apply that to my property, or I've got this particular issue, jump in, because it sounds like you've all got similar sites. And so, probably the question you were asking is a question that others have. And so what I've got prepared is just about how to manage water sustainably. And that's why I try and tailor it, because it's such a big topic, everything from water conservation through to, runoff, through to water quality. I've got a whole bunch of different ideas. So this slide is like an ideas pack, really. And the thing is, the idea is not that you go away and go, I'm going to do these 20 things. The idea is you go away and go, oh, 2 of these things or 1 of these things applies to me. That's what I should do, because that's what's going to make the most benefit. If you're really keen, you can do the next one type thing. But the idea is some of these things will resonate, and then some of them won't resonate at all, and that's fine. That doesn't have to be the case. So it's not the idea that the sustainable house has all 20 of these ideas. A sustainable house maybe has 1 or 2 of these ideas, or sustainable water management has 1 or 2 of these ideas in them. So I'm just going to quickly fly through this. This is kind of just the reason why we do it, like why council does it. And for those of you, for my background, just to understand my background, I do a lot of work with council, Sydney Water, state government, developers, making their practices more sustainable. So we do that for a whole range of reasons: to protect creeks from erosion, to improve the water quality, and ideally so that we get, we have cities that almost more like national parks, that we can go and swim in the waterways, we can go and fish in the waterways and eat healthy fish. So whereas in some parts of our waterways, they no longer can recommend not to eat the fish anymore. And then we get things like this, where in the big tidal rivers, we get sediment that deposits on seagrasses and affects all of the benthic flora, all the things that are growing on the river base, which then goes through, and that affects all of the ecosystem. So everything that feeds on that, and then the fish, and then that works its way up through the food chain. So we're really interested in how we actually address that, not just in the public sphere. So council can do it in their parks, Sydney Water can do it in their channels, but as individual homeowners, how do we make our little difference? And these are some of the, does anyone recognize this? Beautiful local waterway, Lovers Jump Creek. So, it's these types of waterways, and you can see the color of that water there is brown. And so it's the idea of having these beautiful, healthy creeks. If this was, that doesn't particularly look like you want to swim in it. But if this was a, beautiful crystal clear pool, a great spot to take the family down and go for a swim. Just some other examples of, just beautiful local waterways. So unlike where I live in the inner west. I don't have beautiful creeks like this. So, to me, this is heaven. I'm going to quickly flick through this, but just generally, when we urbanize, we have impacts, and part of those impacts is you see in terms of poor drainage, actually. So, because what we do when we change from a forested catchment to a streets and roads and houses and hard stand, we change the way the water cycle works. So instead of the water soaking into the ground, that hard stand runs off quickly. And then we also cut into so when you've got these steep blocks, you're cutting in to sandstone, and you're changing the way water's flowing over the top of that sandstone. So when we develop, we create these water management issues. And typically, particularly when houses were built, 50 years ago, the practices that we do now weren't what we did 50 years ago. So we do things differently to manage the way that water moves through the site. And that's just what I was talking about. I'm going to flick through that. And so the second part of sustainable water management, as well as managing it for the waterways that we're doing is, and it's kind of off the agenda at the moment because we're in, all the dams are full, but if you lived in Sydney through the noughties, drought response and drought management. So what we do is we dam, we've got all of the Upper Nepean rivers, so Cataract, Avon, all of those rivers are actually dammed. So we've had a massive impact on all of those all those waterways that are, on the surrounding fringe of Sydney to supply us with water. So Warragamba Dam's the biggest of them, but there's actually 4 others on all of the Upper Nepean rivers. So we have significant impacts on these waterways. So we've completely altered the way that these rivers work from an environmental perspective. So the more that we can use water locally, the less impact we have on these waterways, the more that we can actually release environmental flows from these waterways and improve these waterways. So it has an impact on our region, and obviously desalination plant, producing water through consumption of energy, given that climate change and the cost of energy, it's obviously there's an importance in being able to limit the amount of energy that we're using to just use water. I'm going to fly through this just quickly, but this, if it's there, if you've got interest in this, just ask questions. But I'm going to fly through this because I think there's a lot of interest just in drainage and water management. But if you are interested, this is important for when you want to use water in the home and how to save water in the home, like how you actually use water in the home. So the first thing is to understand how you use water in the home.
What are the 2 numbers before?
Yeah, so the 20% is what percentage of water is used in a typical home, a typical single dwelling. So if you live in it, most of you mentioned that you lived in, sounds like single dwellings, detached, classic houses in Ku-ring-gai. So these are for those types of houses. 20% of water is typically used in the garden. Now, depending on your garden, if you have a native garden or not very much garden and more paving, you won't use that much. But the typical house uses about 20%. And that number there is 40 kilolitres per year. So that's 40 kilolitres per year of water is used for the garden. But yeah, the number that matters most there is the percent. So you can see the percent of all these different things. So the washing machine, the shower and the bath, the taps and toilets, all of that is what we call non-potable. That's all water that you don't actually need to make drinking quality. And so what that means is that's a good source that you can use for rainwater tanks, for example. So if you can use supply all of those non-potable uses with rainwater instead of mains water, all of a sudden you can change the balance. So in my house, as an example, I have a rainwater tank that captures all the roof water and goes into that tank, and I supply it to everything but my kitchen tap. My kitchen tap is just on mains water potable, but everything else just runs off rains water. And my water consumption has dropped by 80%, and it's a relatively small tank. So it's only 5 kilolitres. So with a small tank, you can supply most of your water. At the moment, my tank hasn't been empty for, I can't remember since when, probably 6 months. It's just been full the whole time. I was going to fly through that. I'm not going to talk to that. Conservation for those of you, you know, lived again, if you lived in through the noughties drought, you would have seen all of the water saving shower heads. But that's the first thing to do. If you're replacing a washing machine, old clunker washing machines use 150 litres per wash. The new ones use less than 60. So, you know, buy water and energy efficient appliances. Don't go and replace things if they're working, and you don't need to. But if you're looking to replace it, definitely look for the little water drip indicator. You know, looking for 4 or 5 drips. Pools. Anyone have a pool? Pools are a huge water user. So pools are a big water user. So one of the slides I had up there, which I quickly flicked through. So if you have a pool, you typically use 20% more water than the average home in Sydney. So pools are a big water user. So supplying that with rainwater is a possibility. But also pool covers. Bit annoying, but you know they do save water. And this, everyone just look familiar? We have big lawns like this. These are obviously big water users. Compared to this, you know, so this is, you know, like a much lower water use environment. So there's been a big change compared to, you know, particularly 30, 40 years ago towards using more natives. Again, I'm just going to quickly fly through that. So one of the things I'm going to talk about, because it's really interesting how when you've got drainage issues, particularly if you don't have well-drained roofs, does anybody have or seen, you know, during this recent period where their downpipes are not properly connected to the stormwater system underneath and are just flowing out over the, yeah, feel you nodding, no? Does anyone have overflowing gutters? Everyone notice their gutters overflowing in this period? Yeah.
I have more of a problem in
Yeah.
that a really large, thick roof.
Yeah.
And I do have a new house downpipe, but the water off the roof is just coming straight off, missing the gutter.
Yep. Yep.
Going
Straight off.
straight
Yep.
off.
Yeah, exactly. So the first thing to do, so like when you're doing any of these, they're the things to fix up. You know, in that case of where you've got, you know, downpipes that aren't connected, it's thinking about where they connect to. Because when it's wet, they're the things that basically just constantly putting lots of water onto your, you know, garden, backspace, paving, whatever it is, you know, driveways, etc. So the first thing to do is to fix up those points that are causing overflows. So in that instance where you've got gutters, it's really looking at the design of those gutters and fixing those gutters. You know, that's the way to manage it in the first instance. If that comes back, sometimes you come back and you get quoted a ridiculous price, you know, saying, well, it's going to cost you, because of your particular situation, it's going to cost you mega bucks. Then you might think of different ways to do it. But it's normally the most cost-effective way to deal with these things is address the issue. So, you know, address the gutters, and sometimes that's leaf litter. So if your gutters fill with leaf litter and constantly filling with leaf litter with big overhanging trees or deciduous trees, gutter guards can be really good. They're not no maintenance, but they can really help just keeping leaf litter out of your gutters. So in terms of managing water on the property, it's this process of looking at where water is flowing and what they're flowing off. So the roof is a big one, because the roof is often 200, 300 square meters on your property of hard stand. So if you can manage the roof in the first instance and get it draining properly to somewhere, that's a big help. So this is a good example of, you know, where I live in Marrickville in the West, like our house is 100 years old. And often the downpipes just connect into nothing. They just go into the ground and go into these rubble pits, and they don't drain very well. And so one of the ways that you can actually address roof runoff that doesn't actually drain anywhere is a rainwater tank. So rainwater tanks are really good at capturing the water, and particularly if you plumb it internally, so back into your washing machine, your toilets and your taps, even when it's raining. So don't just plumb it into the garden. So it's great plumbing it into the garden, but you know, like now, who's irrigated? Can anybody remember? We didn't really need to irrigate all summer. So you know, if you had a rainwater tank, it just would have been overflowing over this period. But if you plumb it into the house every day, you're drawing down that tank 100, 200 litres for your showers, your bars, your washing. And what that does is that every rain event, it's just capturing some of that rain. So it's capturing 3 or 4 or 5 mils of that rain before the tank starts to get full. And so that really helps just take the pressure off. If you do have, you know, lots of water where it's just not draining away from your roof, it takes all that water out. And so that's exactly my neighbour. My neighbour had that. And so they put in a tank, plumbed it into everything. it's reduced it most of the time. Most of the times the backyard has dried up a lot because it was just sitting in there. We've got this situation where we're not on steep blocks. It kind of just sits all in our backyards and just doesn't drain away. It just sits there. So the rainwater tank just takes a lot of that pressure off. Yep. 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 Yeah, exactly. So I'm just going to repeat that question. The question was, if you've got a rainwater tank and you plumb it into an existing house, is that really expensive to plumb into? So it's a very good question. The way that you do it is you pick off what's easy. You pick off the low-hanging fruit. So if you've got upstairs and one toilet that maybe only one person or two people use, but you've got a clothes washing machine that's easy to plumb into in a laundry, and then you've got the hot water system that's all close together and easy to plumb into. You focus on those elements that are easy to plumb into. You don't go and chase, the one toilet that's the furthest away that it requires you to go a long distance. And so it's about looking at where the water using devices are in your house and going, yeah, well, if I put the tank here, I could easily plumb that into 3 things. And it might be just plumbing it into those 3 things that are close. But generally speaking, if you do that, it's not that expensive. So most of the cost is still in the tank. There's a bit of plumbing work. A typical cost for a scheme like this would be about $5,000 to $6,000, of which maybe $1,000 is plumbing costs, including the diversion, roof diversion and things like that. And the rest is in the pump and the tank. Yeah. So this is a setup for that a situation where it's got, the downpipe coming down. It switches to mains, so you still always have potable water. It's got an automatic switching device. If you run out of water, it just switches over into mains water. Then it's got an overflow, and in this case, this overflow is not, this tank is being installed here. This overflow is not connected up, but you need to work out where that rainwater tank overflow goes to. That's what you don't want, just discharging uncontrolled into your garden. I've talked about this, just saying, yeah, the key thing about rainwater tanks, the key message for rainwater tanks is it's really about what you plumb it into. You use a rainwater tank much more effectively by plumbing it internally. I'm just going to flick through these slides. So we use these little cheat sheets, and so for those of you interested, we can provide the slides for this. So all of these slides, you can get this information. This is our little cheat sheet for how to set up a really quick little rainwater tank scheme. So harvest at least 100 square meters of roof, and that means don't just put it on your garage that only gets 5 by 2 square meters. That's not big enough. So you want to get at least 100 square meters of roof. And if you're not sure how to work that out, you can actually go into Google Maps, and you can actually measure in Google Maps, or 6 Maps. If you know 6 Maps, both of those have little measuring tools, so you can measure your roof. And then have at least about 5 kiloliters if you've got a single dwelling with a a garden, or if you've got 4 or 5 people in your house, you want at least 5 kiloliters. If you don't have much of a garden, there's only 2 of you living there, you'll probably get away with 2 or 3 kiloliters. And then connect to at least 3 uses. So that might be your hot water system, your washing machine and your toilets, or your washing machine, toilets and your garden. And so if you set a scheme like that, you'll save a lot of water. You'll save about 50% of your water use if you set a scheme like that. So a very simple little cheat sheet for how to set up a rainwater tank. I'm going to skip through grey water reefs. If anyone's interested, is anyone interested in grey water reefs? Nobody's interested in irrigation at the moment. I'll come back if you are. We can come back to grey water reefs. So I'm going to start to talk about how we manage water on the property now, and different ways of managing water. And these are the different ways of thinking about how it's almost like living with water. So sometimes it's best not to fight water. If you've got a spot that collects water and is damp all the time, it's actually better rather than trying to actually sit there and go, well, particularly because some of these drainage problems, it's very hard to solve just by doing through drainage. It's very hard to actually put a stormwater pipe in somewhere and drain that water away. Or it can be very expensive to put in subsoil drainage. So that's water drainage that's actually below the ground. So it's often better to work with the water and create that landscape the way that the water wants to work. And as I said at the beginning, remember, this is not saying that every one of these devices may not appeal to you. The idea is that 1 or 2 does. So wetlands and ponds are a way of, like, when you've got that spot where you've got lots of water coming into, where you've got lots of water, like one thing to actually do is actually create a feature out of that and have a pond that works in that space. And so directing water deliberately into that space and having water in that space. And that could be subsoil drainage, for example. If you've got lots of water flowing over sandstone that then pops up out of the you know, where you've got a shallow bedrock, because often what happens with the bedrock, water flows through the soil, hits the bedrock and doesn't drain through the bedrock and then pops out. And that's where it gets wet, where it pops out off the sandstone. And if you've got a house that's cut into sandstone, you'll often find that that wall is damp where the sandstone is. And that's very hard to deal with. Like normally if we do that now, we have a false wall and we'll have drainage around that. And so that's very difficult to fix. We've looked at a number of these houses, you know, where it's been put in and you've got this house cut into sandstone. It's very difficult to fix. It's very expensive. But if you've got that situation where you've got something cut into sandstone and water seeping through that sandstone, the only real way to fix that is to cut in subsoil drainage around that, some type of drainage, and to collect that water in between the sandstone and whatever you're trying to protect, the house, the wall, whatever it is. But that's it. That's what's happening. You've cut into an aquifer, and when it rains like this, you know, lots of water is seeping through. So these can pop up in your garden as well. So those of you on steep blocks will see this. You'll see where it pops out. You see it in the bush. You know, you get these little streams that are ephemeral and run through. They can be done in compact situations as well. So this might be more like, you know, the front or the side of the house, but this is one, for example, in Balmain that can be done in a formal way. So there's a wetland sitting in the middle of that. You can see it sitting in the middle of that image on the right, where there's a wetland sitting in the middle of that. And what this is connected into in this instance is the roof drainage. So the roof drainage goes into that wetland and then feeds that wetland and then overflows back out to the back. And one of the things that you always think about is water goes in and water goes out of these devices. How does water move around that site? Just a different example of it. Again, just some different examples of different wetlands. So these are wetlands. The top left is a wetland that's kind of integrated into the side of a deck. This one on the right shows the downpipe being diverted into this wetland, and these are above ground or container wetlands. So they can be very flexible in the way that you landscape them in. And again, it's just a way of managing water, slowing it down. They can also take, if you've got water running off somewhere, they can manage that water as well. So that water that flows off the garden, flows off paving, that can also be directed into the wetland. I'm gonna flip through this one. For those of you interested in natural pool conversions, I'm going to come back to this. I want to talk to swales. So I'm going to talk to swales because that's probably, I think, one of the key things about managing water and the way that we think about managing water, particularly in these wet periods. So swales are really mini creeks. They're a way of managing flows. So what swales do is they literally take water from A to B. And A is somewhere where you don't want water, and B is somewhere where you don't mind it discharging to. So that's the idea of a swale. So if you think of your property and you think about where water is flowing at the moment, some of you mentioned you have waterfalls and water running through. A swale is how you manage that water through your property. And what it is like a creek. It's like designating an area where the water can flow, where nothing's going to be damaged or in the way. And for those of you who mentioned that where you've got water flowing through and it's, you know, it's taking out the plants, it's about having that space that's there and not having that, so that the swale is actually a dedicated zone for drainage. And then what that is almost like a sacrificial area. You know, you might put some rocky material in there that moves that water through that, but it contains it. So instead of going over this wide space, it goes over a narrow space and it controls that water. And you can do that on any scale. You can do that at different scales. And I'll just show you some examples. So the way that you'll know this just intuitively, you will know swales when you go to country towns, because if you see on this road here, it's got no curb and gutter. And so obviously in urban areas, you know, in pretty much all the city, we have curb and gutters. Some parts of Ku-ring-gai don't actually. So I know, you know, West Pymble and some of those areas up around there don't have gutters, and you park on this like here. So actually some parts of Ku-ring-gai don't have curb and gutter. But this is the swale. So the green space, the green lawn there, water runs off the road, over that slope and then into that low point, and then water flows along that into a pit at the end, or a culvert. So water flows along through here, and that's a swale. And what that is, it's just moving water from A to B. It's moving water off the road, down the swale, and into this culvert, somewhere where we want the water to be in the end. So it's moving water, away from where we don't want it to where we do. So how do you do that, on a backyard scale and incorporate that into the landscaping? So this is where, what you intuitively know where water is flowing through your property, and sometimes it can be a side passage. You want water to move through a side passage because water is flowing from the top down to the bottom. And so we've worked on a property in Ku-ring-gai where we've done that. We've basically built like one of these swales down the side passage to help take water off, because water's flowing down the garage, was flowing down the driveway, and then it was flowing into the garage. Connected that, diverted it into a swale that ran down the side of the house and then out to the back, and then continued it so it then cascaded off into a bush block, down below. But this is the swale. So if you see on the image on the left, you can see there's the faint outline of water flowing through there. And in this instance, this is an overflow from a rainwater tank. So you see that in the middle of the photo there's a round circle at the bottom of the tank. That is the overflow from the tank. And so as the tank overflows, it then flows into this swale and then flows along in this swale. And then at the bottom of this, in this particular instance, it actually flows into a little pond. So that, you start to combine these things, but just as a landscape element, it flows into a little pond at the base. And so what this is in this case, so you can see this idea of, I was talking about saying if you've got lots of flows, for those of you who've got flows coming from, say, for example, your next door neighbor, or even sometimes in the worst case scenario, you can have flows spilling over from the footpath and into your block, into your garden. That's when you need to, if you've got lots of flows, that's where you need to have this kind of more rocky looking, appearance, because that's what's causing the flows, and the velocity of water is what's causing the plants to wash out as well. They're actually physically damaging the plants as it flows along, erosion basically. And also it can just be too wet, and that's about having the right plants in there. If it's just too wet in the swale, you plant, plants that enjoy wet feet. And so the idea with a swale is that, wherever this is in the property, it's moving it. So we're moving water from where water is it can be nuisance water that's popping out off the sandstone, or, where the house is cut in and then it pops out from some point in, where the house is cut in and disturb the drainage line, and it's moving it through the garden in a controlled way. And what that is doing is that allows you to keep most of the area outside of the swale dry. So it's a way of just literally managing the water that flows through it. And obviously it needs to go, with the grade. You can't make water go back where it doesn't want to go. It needs, you need to work with the grade. So if those of you on steep blocks, you're quite limited. It's going down the hill as to where it goes. And that may not necessarily always be useful depending on what's happening in your backyard, but that's just the nature of water. So again, this is just an example just of a transformation. This was about keeping water in the landscape too. So for those dry periods, this is an example in Canberra, a backyard in Canberra, where, before, these guys moved into this house, they had, just a scrappy bit of lawn, and it was very dry. For those of you in Canberra, it's, got a lot less rainfall than we do in Sydney. And then, dug out the swale. So this is the swale with the rock lining on the right, with the river pebbles there and some larger boulders. And then they've just created a little bit of drier landscaping up the top on the right. So the material, the soil that's come out of the swale is then just being built up in this corner here. But that idea of what that does, it just creates a moist zone in the garden. So you can actually get gardens that get a bit more water. And then what you can do with that is create slightly different planting and landscaping in that. So you can get some drier landscaping and some wetter landscaping. But it also just helps, you can see that what that's doing, when it's really wet, it's actually just creating a preferential path for the water to flow. So rather than just water flowing wherever it goes, it's actually controlled. Does anyone have, like, just in terms of drainage and the way that we move water around, does anyone have questions about that, or questions about how it would apply to their particular property? And again, for those of you online, if you've got things, just pop them in the chat box. Does anyone have, yep?
So in terms of grading swale.
Yep.
So we've got the steep block.
Yep.
To the back of the house, and similar to your.
Yep.
Water flows through the rock.
Yep.
Into the garage.
Yep.
Out
yep.
The garage. So whenever it rains, it's like natural.
Yep. Yeah, through the garage. Yep.
And because it's on the rock there, would we need to carve into the rock to create a swale?
Yeah. Yeah. Yeah, it's a good question. Yeah, exactly. So it's a good question. So the question for those of you online, the question was like, if the property has water flowing down the driveway and into the garage, and I might be slightly paraphrasing wrong here, and it's flowing through the garage, but it's on rock. So the question was, do we have to dig into the rock? Because that doesn't sound very fun. Or can we build up and build the swale above the rock? So yeah, so that's a really good question. If I had a whiteboard, I'd draw something, but I don't. And oh yeah, we do that. Sure. We're going to try and move the whiteboard over. Do we have a pen? We'll see. Thanks. Well, but so what you can do, so when you've got fall, so yes, you can build up. So you don't have to build into the rock, because obviously, you know, for those of you who don't like, you know, pickaxing away at bedrock, what you do is you divert it just above the point. So at the point where you're moving water into it, you come up a little bit upstream, up the hill a bit, and then you divert it into it. But then from that point, you can literally almost build a channel into that. So you can build rock above it, and so that it will depend very much on the specifics of your house to look at it, but you can. So you can build, basically, you could do it in different ways. You can almost build a brick blind wall, if you think of it that way, because it's easy to think of, but it could also be sandstone walls all the way along, and that is the swale, with the sandstone as the base. Does that make sense? And so you don't have to dig into the sandstone. It can be built on it. But what? Yeah, you need to divert. So the key thing, the bit once you get into the swale is easy. The thing that takes a little bit of thinking about is how you divert it off the driveway, upstream of the garage, before it goes through the garage, into that. And so that might need, for example, if it's a driveway, a greater drain across that, which then converts it into the swale above that. Does that make sense? Because you need some way of getting it from A on the driveway into the swale. And that's the bit that just needs that little bit of thinking, because that sometimes is not obvious. It can be the other way to think about it if you have a little berm. So it can be a berm. So on a driveway, a berm is not that good. But if you think of a speed hump, I'm not saying do this, but just think of it just theoretically like this. If you had a speed hump and the speed hump just directed the water into the swale, that would also work. So there's a couple of different ways to do it. Obviously, a speed hump on your driveway is often not practical. That's why you do a graded drain most commonly. So I'm going to draw in plan first. And so I'm just going to draw this example that I worked on, just because it will make more sense for me this way. So I've got a driveway, and this is water's falling through here, and then the garage was here. And then the graded drain was here. So the water comes down, and instead of flowing through that and through the garage and through where you don't want water, you pick it up into here. Water goes through the graded drain. And then if this is the swale, coming down through here. And then that section, if I draw a section through there, at that point there, if that's bedrock, if that's your bedrock, that's what I was saying, you can build up. You just build up there, your rocks on top, or, you know, a brick wall or whatever, it doesn't really matter. And then at that point there, if you've got steep fall, this point here will be low enough that water can get from here to here. But that bit there is the trickiest bit, is how do you get water from here into the swale and drain it through. This principle applies to any bit where you've got water flowing over a wide area and you want to put it back into this swale, how you capture that water and put it into that point.
How is the situation almost the opposite of that, but water goes behind the garage?
Yeah, the reverse. Yeah.
Yeah, but what you're saying is the tricky bit is actually diverting the natural course of water in the first place.
Exactly. Yeah. The bit that's it's highly site specific. So like as soon as you go into details, I was just saying I'm going to use the one I know, but it's very highly site specific and it varies. But if you think of the two principles, there's two principles the way that you can do it. One is a trench, effectively a grate. That's what this is. So if water's flowing along through here, you drop the water into something. That's the graded drain as a principle. So these are the two kind of, you know, the first principles of it is this. So one is to like, can I put in a graded drain? And then the other one is, can I put in some type of berm? And then both do the same thing. Both are directing water into the swale. Yeah. So that's the principle. So you kind of need to think along those two lines, because what you're trying to do is convert water that's flowing often in a wider bit, and you're trying to channel it into something that's narrow.
That's why you see a lot of those channels with like filled with rocks.
Yep.
Along the side of roads and stuff called bush.
Yep. Yeah, exactly. Yeah, exactly right. Yeah,
They're always filled with a really large.
exactly. Yeah. And the reason why the reason why they have large rock is when it's steep, that's to protect it from erosion. Yeah. Yeah, exactly. Yeah. Yeah, because if it's just dirt, the dirt, if it's steep, will just wash away.
Where,
Yeah.
where do we find people who understand landscape?
Yeah. Yeah, so there's people that are coming through in landscaping who are starting to get this. So often you find the plumbers go straight to PVC pipe and stuff like that. So often actually we find that people actually are small landscaping contractors who actually get this better because they're used to working naturally with things like this. Because this swale, when you do it like this is more like it's almost like a landscaping intervention rather than a plumber who just thinks, you know, I've got to get it from A to B, where do I put my pipe? So landscaping contractors, there's some good landscaping contractors out there who are, you know, who are good at this.
Do you call them something specific that
So talk to me after, and I'll give you a few names, and then that will start you. You know, they're not necessarily people that only do it, but that will if you start to Google, you'll start to get the idea. But one of the people who's good at this, who started to work in Sydney, is Philip Johnson. So Philip Johnson is really good. So Philip Johnson Landscape Architects he builds his own stuff. He's not for everyone's price palette. That's all. You know, he works at that level rather than he works at the Aldi level rather than the Aldi level. Yeah, exactly. Someone who's got permaculture principles will get this, particularly if they've got a little bit of a drainage bent and understand flows and things like that. Absolutely. Yeah, exactly. Yeah, permaculture. So permaculture it's very much like this idea is very much permaculture principles of retaining water in the landscape and working with water. It's just a little bit more engineered, I guess. Yeah. Yeah.
So my property
Yep.
is up on sloping block, but
Yep.
I've got other properties below me.
Yep.
They currently don't have any swales at
Yep.
all. So effectively, when there's huge rain, there's various entry points for water into the properties below me.
Yes.
So if I were to build a swale or to have
Yep.
one put it in, suddenly they've got one.
Yep.
point.
Yeah.
It's got to be council rules or something.
Yeah,
about
no,
it.
exactly. So that's a really good point. And someone good. I'm gonna grab my a cloth. So yes, so yeah. Oh, thanks. So yeah, so we didn't use it. This wasn't us, was it? So yes, so very good point. So I mentioned at the beginning that swales or moving water is about moving water from A to B. So what you're asking me about, what I've been talking about is A, but now you're asking me about B. Does that make sense? You're asking me, okay, I've got it into A. What about B? So that's a very good point. So the first rule of drainage is don't make anything worse, you know, particularly for your neighbors. So if I draw a block, and again, I'm just an artificial block, and say, for example, you're draining, you know, from this way to this way. And as you say, well, if I put a swale in here, and at the moment water's going, some bits going here and some bits going here, and you know, there's a little bit going that way and a little bit going that way. If I put a swale in, you know, and I put it all here, my next door neighbor is not going to thank me for that. Yep, and that's a really good point. You're right. You're 100% right. So that's what I say. The first principle is when you think about B, don't make anything worse. And that means for your neighbors as well. So you can't, you can sort of, but obviously not being very neighborly to do something like this, to manage water by putting it somewhere in there. In new development, you absolutely can't do this. These days, we don't allow this at all, but in existing development, it's slightly different. But there's a couple of key principles to think about is, first of all, our first principle is if we've got, say, for example, I'll just simplify this. Say, for example, we've got 2 drainage points, and that's where water's going at the moment, and all of it's going there, and I'll ignore these, say these don't actually exist. The first thing we say is don't put, you know, if this is this part of the lot, your house that was draining to this point here, keep that catchment, that part of the lot draining to that too. So don't make anything worse. Don't put all of this here into this point as well. So you will, in this instance, you will have, you know, 2 points, 2 discharge points that are retained for your existing. If you can see, and if you've got good relationships with your neighbor and it's actually causing a problem for your neighbor, you can change it. So you sit there and go, well, my neighbor's house actually is here. I'd really like it if you moved it to here, you know, and you look at it and you'll see that logically, you know, peer over the fence and you can sit there and go, is there anything if I discharge here that's, you know, there's a house, there's a garage, there's something at this point. And you'll see straight away, it actually would help my neighbor to put it here. You know, through discussions with your neighbor, you can move that point to that point there. But the first principle is, you know, don't make it worse. Keep those 2 points that you've got. And then you can make it better, but obviously you want to be careful about that. Does that make sense? So that's the B. So I think about a swale is, a swale doesn't hold the water back. It just moves it. It literally just moves it. Yeah. So, and what you can do is, the other thing that you can do along that way, and this is what I was saying, you know, along this way, this is where you start to combine things. This is where the point where you would have a pond or a wetland or a rain garden, where you'd hold the water back, you know, a soak away. And so the water would come into here. And what you're doing then is you're actually being quite good, you know, because you're retaining water on site. And then what you can start to do then, if you really start to then tie these things together, and you start to think about, if I've got a lawn here, so if we start to think about that other part of your equation about how to retain water in the landscape when it's dry, if I've got a lawn here, what I can do is I can actually then have a soakaway back out this way. And a soakaway is just literally something that's flat. And it's just like a classic old French drain, gravel trench. I don't know, does anyone know why they're called French drains? I guess the French use them. But that's my poor drawing of gravel. And that's just a slotted pipe, an Aggie pipe, if you know it. If you know Aggie pipes, they're just literally leaky pipes. You buy them in big coils in Bunnings. And so what that does is water comes into my swale, it comes into my little soakaway, and then it fills up this, and then it just runs out along the contour. Again, permaculture principles, it runs out along the contours. And then what that does is every time it rains, it just waters my lawn and keeps a little bit of water in that landscape and reduces the amount of runoff that's going in. And you can do that. It doesn't have to be lawn. That can be any garden bed. And so that's the way that you can keep water in there. And then what happens, you know, when it's dry, it's fantastic. So it's like this natural irrigation system for your lawn. When it's wet, the downside of something like this, if it is lawn and you want to keep the lawn dry, the downside of something like this is when it's wet, it makes the lawn wetter. So sometimes for lawns, depending on how you use it, if you've got kids that run around and want to use that lawn, maybe that's not great. And so it's sometimes better to do it into a garden bed, because then you don't worry so much about, you know, doing it. Are there any other questions about that? Am I thoroughly confused, everyone? Yep. Great. Okay. So swales, and this is the example of, you know, like starting to tie some of these measures together into these different things.
I'm
Yep.
just wondering if there's somewhat of a crossover between one
Yep, definitely.
landscape.
Yep.
So where do you start?
Yep.
With the plum or the landscape?
Yeah, it depends. It's a good question. So the question was, where do I start, with a plumber or a landscaper? If the divide is hard and soft in a way. So when it's hard, so you mentioned before the gutter problem, that is the plumber. And if you've got downpipe issues, that is the plumber. The plumber will solve will generally be able to give you good advice on those things. Where it flips is in the soft bit. So a good classic example, I had that graded drain. That's typically the plumber. The plumber does will understand the graded drain. That's the hard bit. And then when it flips into the swale, plumbers have the knowledge to do it. They just don't think like it. They don't have the kind of thinking about how to do it, has been my experience. So that flips into the landscape contractor. So when it becomes anything that's kind of got rocks, living things, and those soil, that flips into the landscaping contractor. And who do you start with? It depends on your problem. So if your problem is predominantly one of how do I move it through the landscape, I would say start with a landscaping contractor. But if your one is predominantly one about drainage and drainage issues, I would start with a plumber. Yep. Okay. Any other questions? And I've broken this, Anush. I've totally broken it. What have I done? It's not working. I knew I was going to break something. I said to Anush, I said, I've got it all working for you. It's fine. I said, oh, just you wait. I will break it. So, yeah, thank you. Okay, so I'm going to flip. Oh, yeah. So this is a good photo. So this photo here, as I said, I live in the inner west, and we do naughty things in the west, like guerrilla gardening. And so what you can do these things in this is an example. I was talking about the ag pipe and how you get water from these devices back into the landscape. So that's exactly what's happening here. So we're putting in an aggie pipe that's then surrounded by gravel, and we're doing it in the nature strip. Now it's naughty because the nature strip is actually council's, and you should really get permission for this. And what this is doing is often all your downpipes go out through your nature strip. And so the downpipes are great because you can cut into your downpipe before it goes out into the curb and then water your nature strip. So every time it rains, it just drops out a certain amount of water into that ag pipe, and then it fills back up. It gets to a certain point where it's, it's full of water, and then it just flows back out into the gutter. So it's almost maintenance free. It's just, so you have like a little spitter. So the water comes along, and normally it's just going straight out into the gutter. And then you have a dropper, and so like a 3-piece, a T-piece, and then you have the ag drain below. So water preferentially flows into the ag drain and then out. And then once the ag drain slowly fills up with the soil getting wetter and wetter, then it's full, and then it just flows straight back out into the street again. So it's just this simple little way. It overflows perfectly by itself. It irrigates your garden perfectly by itself. And so in this one here, we then put a whole bunch of just edible things. We put like fruit. Again, if you come back to permaculture principles, we had like, a whole bunch of just, herbs like mint and stuff like that, but also just fruit trees. Yeah, again, this is just the same example. This is Michael Mobbs. Those of you who heard of Michael Mobbs. Michael Mobbs has done this in Chippendale. So you don't need a lot of space to do some of this. Same idea, taking it from, terraces. I'm going to flip through this. Oh, sorry, that's what I wanted to do. I was wondering why I wasn't. I was going to go back to rain gardens. And this is the house. So this I mentioned the one about the swale down the driveway. So this is the swale down. That's the garage where it was flowing down. This is the one that I was drawing. So the graded drain is in the front of that there, in front of the garage there. And then this is the swale coming down by the side of the house. And so it took water that was previously running through here into a drain and then down by the side of the house. And at the base of this is a little rain garden. And the rain garden is just that idea of this at the bottom of the swale in a low point, somewhere where water just ponds. And what a rain garden is trying to do is trying to get water back into the ground. So in this case, we've just planted some ferns in there, some things that really like a lot of water, and in this case, shade as well. And so what the rain garden does is instead of water just rushing off, it actually just soaks into the ground. So it's getting back into the ground. And to make that work, what we do is we dig out, I don't know, like half a meter, whatever you can. If you're on bedrock, you might not even get that far. We dig out a bit and we replace that with sand. And so it's just a soak away. So water fills in, goes into the sand, and then just soaks out and goes away. And it's just a way of just keeping water in the landscape. You don't do this. So you can see this as a way from the structures, walls and houses and anything that you care about. We don't do that around, where you're going to cause a drainage problem. So, you keep it as far away as you can. It's practical from anything that you actually care about. These are just another examples of that. And the way that the rain gardens work is they just have what we call on top a depression. They're just like in the UK, they call them bog gardens, which I quite like. But that gives the idea of these kind of wet gardens. And they have this space on top. So you can see here, so this is Sydney University. So those who know Sydney University have walked along this part. You won't know it because these are all grown up now in terms of the planting. But there's just depressions and they're about that big. And what happens is water just fills up in that depression when it rains. So it's about 100, 200 mils and then soaks into the ground afterwards. So it's just got this little bund around the top. But what water doesn't stay there after it rains, water flows into the sand and drains away. So that's just a simple way of keeping water in the landscape. And again, same as the wetlands, you can do these in containers too. So these are just different examples where, you know, particularly if you've got, you know, if you've got bedrock or something like that, you don't want to dig into, you can't dig into, you could build it even off a rock ledge. It could be built into a rock ledge above ground off one of the rock ledges, for example. So where the rock ledge drops, the thing could be built up above ground on top of the rock ledge. Again, just another way of managing and slowing down that water. Okay, is there any questions about that? Any queries about the rain guns? Okay, yep, great. Come back, go through, talk to that. Green walls. Green walls are for the keen beans. So green walls are really good actually for thermal insulation. They're actually really great for thermal insulation. In terms of water management, they're good if they're linked to using water, but there actually can be very high water use. So if you know pots, you grow plants in pots, you're constantly watering pots, particularly if they get any amount of sun. So the thing about green walls is that they do use a lot of water, and so they can actually be linked very well to keeping water on site. And if you've got, if you do have a hot western wall, for example, they can actually be really good to keep that wall cool and minimize your heating bills. But from a water management perspective, just naturally, they don't do a lot. So, this is a great example. This is actually in Annandale, and this is on a north-facing wall. And the idea is this is providing, thermal insulation to the building behind. And this is, if you know the ones across from UTS, One Central. So this was the precursor to that. So Fraser's built this one. This was their trial before they built all the ones at One Central. And this is used, and the ones at One Central are all used actually using wastewater. So it's a way of actually reusing wastewater on site. So they both use treated wastewater. Flip through that. So green roofs are a great way of managing water off the roof. So roofs are the biggest, when you look at your lot, most of the water from your lot is coming off your roof, unless you've got water flowing in from the other properties. So green roofs are really fantastic at maintaining the natural water cycle. So they reduce the amount of water runoff off your roof by about 80%. Not this year, but on average, they will take 80% of the water off your roof, which is incredible when you think about it. That can do that. Sorry, I missed that. It doesn't have to be. Have I got a picture in here? I don't. So yeah, they work best on flat roofs. But there is an example in Angel Street. If you type in Angel Street, Erskineville, that's on a classic 33-degree pitched roof, they generally work better on flat roofs. So when you do it on a pitched roof, you have to really think about it because it can go wrong. And it's hard to maintain on a pitched roof. When I've seen this one, I go past this one quite a lot. They literally have to abseil into it to maintain it. so yeah, on a pitched roof, it's much harder. But yeah, and the other thing about green roofs is they don't work well with rainwater tanks. So if you're doing it to maintain water, like rainwater tank is much easier than a green roof. So a green roof really, we don't recommend doing a retrofit with a green roof. It's really hard. They work much better if you're doing an extension or something like a garage that might be replacing the roof or something on. It's hard to put into an existing roof. It just structurally and waterproofing, it's quite difficult. So yeah, so again, green roofs, they're very useful, but they're very particular. Like we find they only work in certain situations. So we've only really done them on extensions. We've done a very small one on a retrofit. These are just some examples. So porous paving. So this is another way. So porous paving is a really good one of managing that excess water runoff. So if you've got water from hardstand flowing over your property, so you might have a driveway, for example. So porous paving is one way of managing the hardstand, where you want the hardstand. You can't just return it all to turf or planting. So it might be a path, it might be somewhere where you've got seating or whatever it is, courtyard, etc. And normally, that if that's just standard paving, it just runs off, and can create, issues in terms of wetness, particularly if it doesn't drain very well. So porous paving is a way of getting the water through the paving and back into the ground below. This one does it here through the little gaps between the pavers. So you see that? So each little paver has just a little gap. So this is what I call dumb porous paving in a way. Like we could all do this just by leaving out one paver, so that's, and then I don't particularly like this type of paving, but it's the one you often see because this gets weeds in it pretty quickly. And so if you're ever pulling out the weeds, so I'm not a big fan of it. But you see it. And then this is the type of paver I prefer. This particular product is called Hydroston. And what it is the paver itself is porous. And it's actually just a coarse concrete without the fines. And so water flows through the coarse concrete. So the concrete's just not permeable. And then what it does is it literally, this is amazing when you see, this is actually a project that was done in a lane in Enmore. So if you know Enmore Road, this is right behind Enmore Road. And they've kept, so this is just an access lane to a few properties, so it doesn't get a lot of vehicle traffic. And so they kept the vehicle bits, and then they put this little bit of planting in the middle, and then you can just drive over the outside. But this lane was, typically just asphalt. And they've just, when they redid this lane, they just replaced it all with porous paving. Underneath the porous pavers, if you've ever done paving, you have a sand bed underneath. With porous paving, you can't put a concrete bed because that keeps the pavers in place, but it stops the permeability. So underneath the porous pavers, you have a sand bed or gravel, and that's what helps. The water goes through the paver, sits in that gravel bed, and then soaks back into the ground. If you've got very clay soils, you want to have a good depth of gravel, because otherwise it's just going to sit on the clay. But yeah, porous pavers are a really good way of managing things in certain situations. Most of the time, and these are all just different examples of them. So you can do, gravel pave. This is just what I call the egg cup one. They're just like little plastic egg cups with deco granite in it. Useful for driveways. This type of thing doesn't work very well on steep sites. So for most of you, this is not going to be appropriate because it just washes out. If you're thinking about porous paving, you want something that's more like a paver. Yep.
Do porous pavers in the shade, do they get very mossy?
They can. So yeah, we're all kind of dealing with that. If you've got any type of paver, they can. But they're actually better. So they're actually better than normal pavers. Well, sorry. I'll clarify that. Can I come back to it? These pavers are no different. These pavers are no different to any other paver. So if you've got an area that doesn't get much sunlight and gets damp or lots of runoff off it, this will be like any mossy paver that you've got at the moment. It won't be any different. This one is actually better because it drains through. So it doesn't stay, they actually dry really quickly. So this can actually help manage if you've got a slippery area. Porous pavers, this type of porous paver like the Hydroston, there's a couple on the market. I think Boral have one, Hydropave or something like that. They're actually better for keeping the pavers dry. Who has slippery pavers at the moment? Has everyone got? I've got slippery concrete at the moment in one spot. Yep. Is there anything? Yeah. So that's kind of where I've got to in the end. I've skipped through a few things. Was anyone interested in anything that I skipped through quickly? No. Okay. Anyone got any additional questions? I'm happy to spend some time, asking if you've got specific queries and questions to go into those specific queries and questions. And for those of you who are happy, by all means, feel free to slowly say goodbye. Yep. Yeah. So there's a comment about native landscaping. So native landscaping is much better for water use. And also generally for, managing, if you've got soggy areas, you can put water-loving plants in there that actually evapotranspire more. So certain plants will evapotranspire more than others. So some plants, for example, if you put dryland plants in and it gets too wet, they kind of just go, they partially die, like they senesce. We use the term senesce. They senesce, they kind of go brown and they don't like it. So they're actually not evapotranspiring anything. But a water-loving native grass, for example, is called carex or sedge grass. It actually will keep going. It loves it, thrives on it. It's a boggy plant. It grows on the edges of wetlands in dry soil. But when it's wet, it just loves it, and it goes green. It goes really bright green when it's wet. And so there's a bunch of plants like that. So any riparian species plants like Isolepsis nodosa, or a whole range of different plants like that. That Garnia is another native saw sedge plant. All of these plants, they actually evapotranspire more. And what that's doing is they're taking water out of the soil and putting moisture back into the to the atmosphere. And so they're the ones that can actually help, just with those plants can actually help dry out the soil. And then if you can get a tree in there like a melaleuca, again, they will help really dry out the soil, because they'll enjoy those conditions. They'll take in the water, and they basically walk like a little water pump. You know, they're taking water out of the soil and pumping it back up to the atmosphere. So where you've got boggy areas, you know, that's the worst thing for turf in the sort of way. If you've got boggy area and you want to keep it as turf, the best thing you can do is has anyone got that situation? You can actually put sand slits in the turf. Has anyone come across sand slit drainage in turf? Sand slit. So not Sanskrit, sand slit. So what you do in the turf, so we do this in sports fields. So this is really common in sports fields. And what we do it in sports fields because the sports groups, who still plays sport or got kids that play sport, sports groups are they're very demanding. I've got young kids who play sport too, so I know this, but they do not like, if you notice this, they do not like it when the fields are closed by council. So what that pushes councils to do is they want to keep, the reason why councils close the grounds is because the kids chew up when adults chew up the ground when they play on it when it's wet. So what we do in sports fields is we put sand slit drainage in, and what that is if this is the cross section through the turf, we put in little sand trenches, and you can do this in your backyard too. So you literally kind of just, I'm talking like this wide, and we put in a little slotted pipe or an Aggie pipe, and then we just drain that out. So each one of these has, so what that does is the water's running off, it goes preferentially into the sand slit. So in plan, if this is your lawn and it's draining this way, this sand slit trench goes across in perpendicular to the flow. The sand is there, and then that's draining out. And that can just drain out into the garden. In the sports field situation, we drained it into a pipe and drained it out. But then you have multiple of them. And it's amazing how effective these are at drying out a lawn. They're actually, sometimes they can be too effective and they dry it out too much. Actually, it means you get more irrigation, but they're really effective. And so this only needs to be 200 mils deep, and this only needs to be 100 mils wide. So, you're digging these very shallow, small trenches, and then you're just putting a little, you're putting river sand or coarse wash sand, which most, landscape suppliers will have. So something that's just a coarse sand, a beach sand, effectively, something that drains really well. And they're really great. You can do this in your garden too, if you've got wet areas in your garden, and it's like an underground swale. It's just moving water. So if you've got the same thing in your garden and you've got this area and you want to move it out, you can just put this on the ground and take the water over here. And if you've got a water-loving tree, you can just wrap it around the tree. And the tree will then, the tree will, if as long as it's a water-loving tree, the tree will enjoy it. The trench? No, interestingly, no, not really, because it works through hydraulic head, like just the water building up there. It helps if it does have a bit of slope, but it doesn't need to. So yeah, it doesn't actually need to, because it's just a preferential thing. Compared to flowing through the soil, this has got no resistance. So it will just take that path. Water takes the path of least resistance. So these can be laid flat. So it's a good question. But yeah, it's interesting. Specific questions? Anyone got?
I have one.
Yep.
Very specific
Yep.
to our
Yep.
backyard. We have a side slope.
Yep.
On our upside, we have a massive rock comes out from the retaining. So the next door's fence is
Yep.
on our rock.
Yep.
And the rock is fairly close to the house.
Yep.
And at the base of the rock, previous owners, there's quite a probably 3-meter area at the base of the rock.
Yep. So your house is cut down in here. You got a house up the top.
Yeah.
So that's the house. And then it's dropping down in here, and this is your house.
Yeah.
Yep.
And then
Yep. The base of this.
Between the rock and the house,
Yep.
there's a nice pond.
Yep. Yep.
But the pond is up against the house.
Yep.
And the previous people had concreted the bottom, for whatever reason, concreted the bottom of the pond.
Yep.
And I have had a couple of people come and look at it and they don't want to knock out the concrete.
Yep.
Because I guess they don't know what's underneath.
Yep.
And I assume it's just all rocky.
Yeah. Yeah, I mean, it's very possible this is all just bedrock. If this is all, yeah. So normally what we do is, like in that situation, the first thing I just want to make sure this doesn't leak. And what you can do to protect it from leaking is just put a pond liner over the top. So that's one thing. Do you want to take it out? Is that?
I don't really mind either way, but
Yep.
the water seeps into that area from
Yep.
under the rock.
Yep.
As well as not much over the rock, but
Yep.
it seeps from underneath.
Yep.
And fills that area. So a pond liner
Yep.
over the concrete.
Yeah, if it's on the base. So one thing, like if this, one thing I would just make sure, like you've got your foundations of the house, piers or whatever, depending on what this is, assuming it's could be slab on ground to some extent. But one thing I always get nervous about with things like this is I don't want water here, next to the house.
At the moment, there's just an ag drain
Yeah.
up against the house.
Yeah.
But it's open-ended because it was left for us to do our landscaping.
Yeah.
Which hasn't been done yet.
Yeah.
So the open end is basically working not just as an egg drain,
Yes.
but as the water
Collection.
that comes out.
Yes.
We've built it in a wall around it so that the water goes down the egg
Yes.
drain as opposed to just soaking into it.
Yes. Yeah.
And I guess it was just a matter of
Yeah.
what do we do? Take the chance and take the concrete out.
Yeah.
And
Yeah.
then we have a really big hole.
Yeah. Yeah.
We
There's-
don't know what to do.
Yeah, there's a couple of things, like you don't necessarily have to take the concrete out. You could potentially, there's a couple of things, and it's very site specific, so I can't answer that question. So that's my first thing. I can't answer that because I just don't know. But, there's a couple of things that just jump to mind. If you don't want that there and you just want this to drain, so in plan, if this is the house, and I'm assuming it drains one way or the other, so this is higher, and so there's some water must be coming off here, a little bit of water, but then as you say, there's water coming from underneath. And what that is partly doing, I suspect, is I was saying when you cut into sandstone, you disturb these kind of aquifers or, flows coming in. That's partly what's happening there, but on yours, it's not just front to back, it's sideways. And so what you generally want to do, like what I want to do, if I was doing this from scratch, if I talk about my first principles, if you look at that Ku-ring-gai house that we looked at before, the first thing is I personally don't like doing anything next to the house. Because that's the bit that you care about. That's the bit that you don't want to have structural foundation damage. And generally speaking, we want to get water away from the house. So if I just ignore the fact that there's a pond there and just say, what would my general advice be to you? I would try and get water away from here into somewhere where it's just in the landscape and is not sitting next to the house. So a pond sitting here is not necessarily bad per se, but it probably wouldn't be my first choice of where to put a pond, if that makes sense. I wouldn't put it there. I'd put it into the landscape where there's more, a little bit less risk, I guess.
The landscape actually starts going uphill, so that is
The low point. Yeah, so that's tricky. Yeah, because then and that's what you're saying. So that's when you got to think about, how does that drain out? That's how do you get, if all the water's coming into here, then I'll be saying, okay, what I really want to do is I do not want all the water coming to that point. How do I actually have a swale, or as you say, your ag drain that comes out and drains that somewhere out? So I'd be wanting to get water, even if there is a pond, I want to get water out of that particular situation. I don't want all the water next to the side of my house.
Would an ag drain really be, maybe that's the question.
Yeah.
Would an ag drain be enough to?
It depends how much water is coming off here. If this is just seepage water, possibly. If you're saying most of the water tends to be just coming through the rocks and underground, an ag drain is possibly enough. But if there's surface flow, if you've got roof water and if you've got paving or driveways flowing over here, no, it probably isn't. But if it's just seepage, it's probably okay. Do you have damp walls? Is this damp at all? Do you have rising damp on this side?
It's actually up against part of the house that is, I suppose, the foundation of the patio.
Yeah.
But the some plumbing has been put around part of the house.
Yeah.
But it actually goes, if there is a pit.
Yeah.
Not far from there.
Yeah.
And it goes under the house.
Yeah. Yep. Yeah, it's often, yeah, exactly. So that's often what, like if this was a trap low point, we call this a low point where water can't naturally drain out. That's what we do. We put a pit here and then that drains out somewhere. Like, yeah, if you say it might go under the house and out somewhere, but that pit is probably doing the function. If you've got rising dam, we're going to talk about, just mention rising dam. Rising dam is a classic situation of where you've got water ponding against the house. Like that's, if you've got rising dam at the moment, like now is where everyone kind of gets those rising dam, you know, mold growing on the walls. That's because of poor drainage next to your house. And that's why I say, like, you know, everyone who's got rising dam will have it right now. And those of you who don't have it may have it now. Normally, that's why we keep water away from houses, because of rising damp and also just structural damage. Yeah. Has anyone else got any specific questions about their situation? Anything online? No? Okay, fantastic. Feel free to come up and chat to me after if you've got if you want to ask some specific questions as well. I'm more than happy to chat afterwards. Thank you.
Thank you, everyone. For the benefit of everyone on the Zoom, we will be sending out the links to this recording as and when we have it online. So you've got something to refer to. If you'd like the slides, just to go through the slides which were not covered, there's a lot of useful information down there too. We'll be happy to share that too. And I think James will send you some links to the council rebates, etc., all the opportunities that you might have where the council can support you undertaking any of these projects. We'll send you those links too. So thank you all for coming and also for joining us online. And thank you, David. Take care.